PLO B Collision Theory. Well, all chemical reactions, all of them, are the result of collisions of particles. And these collisions have to have two properties. There must be sufficient kinetic energy, that is, they have to be moving at each other fast enough, and they must have correct geometry. They have to be lined up properly. Those two things. So a successful collision is one in which products can form instead of the particles just bouncing off each other and not changing. Here's a particle, A connected to another A. And let's say that it's flying into a second kind of particle, B connected to a B. Before, they're moving towards each other at high kinetic energy. During the collision, they collide together, forming a brief, high energy, unstable product that allows the atoms or particles to reform into new species. It's called the activated complex, and we put brackets around it in a star to show this instability. Afterwards, we see the particles fly together in a new form. Well, I'd like you to consider an exothermic reaction. This is one like a burning match, where energy is being released overall in the reaction. We can diagram this on a potential energy diagram. And I'll just write PE on the vertical axis. On the horizontal axis, I'll write progress of reaction. On the left is the beginning where the reactants are flying together but not yet touching. As they begin to collide, energy is stored, potential energy. It's the energy that allows them to spring apart later on, but it also is the energy that allows them to reform into products. As the new products begin to fly apart, the stored energy decreases, and since it's exothermic, more energy is released than is put into it. Here I'm showing the energy of the activated complex. In the middle is the energy of the reactants, and the bottom is the energy of the products. You can see that the reactants have more energy than the products. Now there are two kinds of energies in this diagram that I would like to point out. First of all, there's the energy increase between the reactants and the activated complex. That's the energy needed to make the reaction happen. So if you look at A2 plus B2, that green arrow shows the energy that was put into it in order to get the molecules to react. So we call it the activation energy. It acts as a barrier to the reaction that we have to get over. The difference between the energy of the reactants and products is called the change in enthalpy. Enthalpy is just a word that means energy in bonds. It's potential energy. And we see here that energy came flying out of the reaction. So E act is the activation energy. It's the minimum amount of energy, kinetic energy actually, in a collision needed for a successful or an effective collision. That is, one that forms products. The delta H, the change in enthalpy, or change in bond energy, during the reaction is shown with this symbol. Well, that's it for now. Thanks.